All right, back to nuts and bolts. Should buy a blankie. Got your blankie?
Yes.
I know. This is my office. It's freaking cold. All right, it'll be hot soon enough.
That will keep you awake.
Yes. And we can keep the meat in here without it going bad. All right, so I want to cover some of the nuts that we use. I don't expect you to memorize the numbers. Just kind of get familiar with them a little bit because you're going to be using them. So as I said before, we have the AN365, the MS-2365 full profile means it's tall. So if it's tall, it means it's going to be a tension type nut. Has a nylon insert. Can you reuse it?
No. Finger tight.
It meets the minimum short. You cannot use these nuts where? One,
Engine.
subject to rotation. Two,
Adjusted by the engine.
can get adjusted by the engine. Very good. Usable to 250 degrees, tension or shear. Let's see. These are the little versions. So if they're not as tall, look at, there's only like 3 or 4 threads inside there. So if you try and torque this, what's going to happen?
Strip it.
Strip it out. So it's 3/6/4. It's a low profile. You can use it for
Shear.
only. Otherwise, same rules apply. This is the high temp self-locking nut. Notice they removed the nylon, and they've got a guy who hacksaws out these little sections of it and crimps it in. So the edges are crimped in, and that's what grabs it. So I say high temp because they're only good up to 450. After 450 degrees, the cad plating starts to bake into the base metal, and they get really brittle. So you don't really use them for exhaust nuts. Castellated nuts, talked about those. The 310 is the taller one, which is for what type of load? Shear, tension? Tension. And the small one is going to be for?
Shear.
Look at that. I mean, there's barely any threads on there. They're easy to tell the difference. This is an interesting thing. I don't know why it ended up in this slideshow, but here it is. So I will tell you about this. These are called Tinnerman nuts. So self-locking screws, or self-threading screws, go in here. This is the backside of a piece of upholstery cover in a Bonanza. So we've got 1, 2, 3, 4, 5, 6, 7 screws. A little bit of blue right there from fuel staining because that's where the fuel lever goes right through. So it's upside down, so you can see it. What's missing?
One of them.
Huh? One of them. So we had just finished we had to rebuild the fuel selector valve. We had to install a new fuel pump. And when you do fuel selector valve, it's kind of a scary thing because if you mess up in aircraft, you turn off the fuel. On this one, there's an off, a left, and a right position. There's no both. Like my airplane has off, right, left, both. Some planes are just off, right, left. So we rebuilt all this, and I was very concerned about doing it. So we went through, some checks outside of the book to make sure it's fine. We would put it in the left tank, and we flowed out through a hose, and we flowed it for a couple of minutes, make sure it's really going to flow. Went to the other side, flowed for a couple minutes, went to off, make sure it didn't flow, make sure everything was fine. Did everything, no leaks. It was leaking real bad. So everything is fantastic. Customer takes the plane, and then he calls me up. He says, I got a problem, man. He goes, luckily I just landed and I fueled up and I went to switch tanks and the fuel selector valve is locked up solid. I can't move it at all. Wow, man, I don't know, we screwed up something. I'm thinking through how we rebuilt it, nothing. I couldn't think of a single thing we could have made a mistake on, but yet fuel selector valve was locked up. Well, lucky for me, he flew it all the way home on the tank that worked. Maybe not the best choice, but worked for me. So I told my mechanic, hey, let's go get the plane. We got to take it apart. We got to redo everything. This is a day's worth of work plus, maybe 2 days worth of work to redo everything. We're just like, my comment was, well, there goes any profit we ever made on this job. So pull the plane up to the hangar. He opens the door, gets in. He's in there for 30 seconds. Found it. I'm like, what? Found the problem. See that missing piece? Fell down and got stuck in his fuel selector valve.
Ooh. Shit.
Yeah. Yeah, that's the fuel selector valve that piece right here, this rotates. Locked up. A lot of people with fuel tanks that are off, right, left will actually fly a tank to dry. Because what good is 1 gallon of, or 2 gallons in a fuel tank? You have no idea when it'll quit. So when you get up to altitude, you can just go ahead and you'll maybe balance out a little bit here, a little bit there, or run one completely dry and then fly on the other one. If he would have done that and drained one tank thinking he's going to switch to the other one, that was it. That was it. Now, I'm very thankful we had nothing to do with this little green thing. That was somebody else did that. We just didn't think to take this cover off, turn it upside down, and check everybody's work. So, I told him what had happened, and I said, man, I am going to take all of these off, and we're going to use actual self-locking nuts and bolts and screws. I promise you this will never happen to you again. And I'm thinking to myself, 1 in a million shot, never happen again. The very next bonanza to come in my shop,
Same thing.
we had to do an annual. I pulled the cover off, and one of these is sitting just like that. Just off to the side a little bit.
That's great. Damn.
The one thing they both have in common is they were both worked on by the same person before me. So I don't know if that was an indicator or... Yeah. There. That was my fix. Got rid of and put on self-locking nuts. So I guess I thought I'd share this with you. I forgot all about it. It was just a few weeks ago. All right. So that's our torquing. So big takeaways from that. Wrench size is not the bolt size. We're going to put a washer under all the aluminum. Even though I'm telling you that, I know several of you are going to put a lock washer up against the aluminum. But that's okay. I will say redo it. You won't. So we're going to learn a little bit more about torquing. So to torque a bolt, you already know how to measure a bolt. You already know how to figure out the thread pitch. You already know how to read a torque chart. So that's pretty much done. So all I got to do is tell you there's torque wrenches. And there are different type of torque wrenches. The things that you don't say sometimes, you think, I don't need to say that. And then a student proves you wrong. So there are different type of torque wrenches. I like click type. So this is a click type, and what you do is you look down here, there's some numbers, and you unlock it, and you twist it, and I'll help you if you have use one of these because you can't see it from here. And you will twist that until these numbers line up, and it tells you what kind of torque you're putting on something. And you gently, right here it's called knurling, and you hold it right here, and you gently pull, you don't jerk it, until it clicks. And the head, if I can do it, it's not battery operated. The little head has a spring in there, and it just kind of, there, clicks over. That's how you know it was done. So you can pull, it'll click, and you can keep pulling. You just have to know when it makes that little sound, stop. So I had one student one time who stripped out every single bolt in the project. I mean, ruined every bolt.
Damn.
So what the hell happened? Well, torque wrench didn't click. And I'm like, clicks just fine. They go, oh, I thought it made like a click, 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 click sound. I'm like, there's no batteries. So 2 things that astonished me. One, that they thought that. The other one is that they ruined 5 bolts. So, ruined that one. Ruined that one. Ruined that one. I'm not done yet. I got 2 more to go. So, I like click type for the very reason you can set it. And especially when you're building engines, you're putting a lot of torque. It's hard to get your face down to read a dial. You can feel it. And I think I just like using it more. The downside to it is sometimes it'll tell you to pull a torque and hold it for so many seconds, and you can't do it with the click type. You have to use a dial type to do that. So this is a click type torque wrench. When you're done with them, you're supposed to set them at the lowest possible setting. Not all the way unscrewed, but like this one started at 40 inch-pounds. You'd put it at 40 inch-pounds. Some torque wrenches are in foot-pounds, some are in inch-pounds. I know I'm forgetting something. Okay, torquing. Yeah, basics of torquing. So when it comes to torquing, we're given a number that we're going to twist something to. So, like we looked before, I don't know, if something was, 50 inch-pounds. Well, that's literally 50 pounds on a 1-inch arm, or less pounds on a longer arm. And so we're going to twist it until we get a certain amount of twist on that bolt. Well, in a perfect world, the engineers would never have us do that. That is a substitute to what they really want. So what an engineer is really doing when they think about torque, especially on critical items like cylinders and stuff like that, it's all about preload. So you take a cylinder that is bolted on to an engine, and so we got a piston going in here that's making the power. So up in here, right, we got the fuel air mixture that's ignited that pushes the piston back out against the crankshaft that rotates the crankshaft. So every time this fires, it's pushing a piston that way, but it's trying to push the cylinder that way. Follow? Mm-hmm. All right. Well, when you torque this on, you have to torque the studs, the through studs and the base studs. You torque them and put more preload on them than this ever has trying to leave. So the engineer is thinking, okay, if the cylinder's trying to leave, and I forget the numbers, let's say 11,000 pounds going this way, the bolt has to be stretched more than this trying to leave. So if this is trying to leave with force X, this has to be under more force. And in a perfect world, what they would have us do is tighten it and put a gigantic micrometer across it and tighten it until we stretch that bolt to a certain point. They would say, okay, if you stretch that bolt to a certain point, that means that that bolt has more tension on it right now than it will ever have from the cylinder. Because if the bolt had less tension, every time this fires, it's going to microscopically move a little bit and stretch the bolt. And then it'll relax and stretch and relax. And it's going to get to its breaking point one day and just snap. And I actually see that very often in airplanes that were dry torqued. I used to keep a plane over here, a guy I shared a hangar with. Hey man, you know anything about engines? I said, I've seen a couple of YouTube videos. Why? And he said, the studs keep coming out of my engine. It's like something every third flight, man. I'm open the cowling, they're missing bolts. Man, that's a real head scratcher there. What happened is somebody put his engine together dry, and so they missed 40% of that torque. So every time his cylinder fired, it stretched the bolt. And so every time it goes flying, one of them fails. So his engine's, I did tell him, I said, it's a pretty serious problem. You want to get that fixed. Who built your engine? Oh man, some AMP school. Okay, then. That wasn't a good idea. So we're twisting to get a stretch. In fact, this is a connecting rod. These are under a tremendous amount of stress. And the bolts that are used here, most of them are torque bolts. You torque them just with the torque wrench. But on some of the real high horsepower, especially Lycoming engines, you actually do use a micrometer. They're machined on both ends, and you tighten them until they get to a certain length with the micrometer. It's a very interesting process. So, prove my point. So we want to be very careful. Nice, steady, even pull till it clicks. Click. It's okay to do it again. I like to do 2 clicks because it's fun. So 2 clicks. So we have that type of torque wrench. The other one we have is the dial torque wrench. In my personal opinion, this is probably the worst torque wrench I've ever seen. I hate it with a passion. And the reason why, because it goes all the way up to 600 inch-pounds. That is a lot. And it's really short. So if you're going to try to do 600 pounds with this little short arm, you're going to be shaking and trying to stare at the dial at the same time. So I really hate it. I think this would be a much better torque wrench if it was 0 to like 300 inch-pounds and the dial was bigger. But it's got a dial on it. And so you just pull it, and as you pull, the little dial on it is going to move to where you want to go. And when it comes time for you to do this, it would make more sense if you came to me and said, yeah, I don't understand how to use this, and I can show you in the shop. I have a tool that will help us do that. If I explain it right now, you'll be like, what the hell did he say? So we'll just keep it short. The other type is the beam type. These are actually pretty cool. How about my office? They're old-timey. What's great about these is that the handle pivots.
Oh, sweet.
And it's like a game. You have to make sure that this bar does not touch the inside of this handle. And if you do that, you're pulling perfect torque at that pin right there. And it teaches you not to twist your arm when you're torquing something, because if you take this one and you twist your arm, you actually can lose some of the torque value. You sort of cheat it out of it. So that's why you have to pull very straight. So pull on this one here. This one you got the cool game. We got to keep the little pivot in the middle. And this one has the knurlings right here, so you should have your hand right about in the middle right there. If you hold it down here, you're messing it up. It's got an effective length right here. Now we have electronic ones. When I was in the business, these things were thousands of dollars when they finally came out. I'm like, not buying none. My father-in-law gave me this one right here, and I brought it in to calibrate it. It cost like $20 at Craftsman, Sears. And I tried. It's probably the most accurate torque wrench I own, which is hilarious. We did that. Oh, didn't I mention that the wrench size is not the bolt size? Okay, good. All right, when we deal with torque wrenches and torquing something, you're asked to put a certain amount of twist on a bolt. I don't think I can draw a bolt. No, I can't. Right, so you got the bolt and you have an arm and you're going to twist it. So if we said 100 foot-pounds and this bar happened to be 12 inches, how much force would we put out here?
100 pounds of force.
100 pounds. That's 100 foot-pounds. That's 100 pounds at 1 foot. That's 12 inches, which is the same as 1 foot. So that's where that comes from, 100 foot-pounds. And we could do some math and we could say that, well, if this was 10 inches, then it would be some other number, which I could probably figure out real quick, but I'm not going to. But it'd be more. 100 and, what's that be, 120, so like 120 pounds, I think? Yeah. Because that'd be 1,020, that also gives 1,020, so probably like 120 pounds. I'm making up some numbers, but I want you to get the concept. The shorter the bar, the more force you have to put on. And what's the bolt going to get? Oh, it's going to get 100 foot-pounds, and that's this one right here, it's going to get 100 foot-pounds, if I did my math right in my head. Well, sometimes you have a hard time getting into something, because this is going to take a socket straight down on the nut. And you can't do it. You got to have a little tool to get inside of something. That's called a torque adapter. And we use a torque adapter or a crow's foot or something like that. Here's a torque adapter right here. See how they put an adapter on the end of the torque wrench? So where the socket would normally go here, now we move the bolt way out to here. Torque adapter. Well, now the torque wrench is going to lie to you because we've extended the arm and we're still putting the same, in my example, 100 foot-pounds. Dial's still going to say 100. We're going to keep pulling here. It's going to put 100 to that, but this is going to multiply it out and give us more torque than we asked for. And so what's going to happen to the bolt? You're going to over-tighten it. Or maybe you do it the other way around. Now it's going this way. Now it's going this way. What the heck? I give up. Oh, I know why, because I keep doing it. Okay, now it's going backwards. So what happens when you torque it now? It assumes that the length goes from all the way to here, but it doesn't. It only goes from here to here. So it's assuming that you're torquing on something right there, but you're not. You're torquing there. So the arm got shorter. So if you put the same 100 pounds on there, what happens to the torque on a bolt? It's less. So the other one gets more, the other one gets less. So this is a real common thing. So we have to figure out how to compensate for this. So it's a simple formula. to compensate. And now we're going to do a lot of formulas in the program. I don't ever require you to memorize a single formula. Now, some of them we use so much every day, constantly, that you can't help but to memorize it, so I'll expect you to. But it's just going to be something simple that you will use every day, so don't worry about that. But like a formula like I'm going to show you now, never ever expect you to memorize it. Never. I will expect you to understand how to use it and be able to use it, but you don't have to memorize it. So to do something like this, the formula right there is given to us. T times L, L plus E equals Y. Which is to say, in this example, if we want, let me see, what's the example say? We want to torque a bolt. If it was right there, we want to torque it to 135 inch-pounds. So we want to torque it to 130, that's my goal on a bolt. But I've got to use an adapter that is 2 inches out. So that's going to change everything. So I'm going to use this formula. T times L divided by L plus E equals Y. Y is how much the dial should say to give me the right torque, to give me the 135. So if I look down at the formula, T, that's my torque. What do I want? I want 135 inch-pounds times L. What is L? That's the length of the wrench. And that's given to me as 10. And I have to divide it by L. I just told you what L is. 10 plus E. E is this piece right here, 2 inches. So that's 1350 divided by 12. And that equals, well, because I'm really good at math, 117 inch-pounds.
Would it be off since the E here is 1.5?
Oh, it's 1.5. Ours are 2 inch. Sorry. I didn't even do that. Yeah, 1.5. Yeah, I screwed up. So it's 1.5. So that makes it 11.5. There we go. So it's 117. So that means in order to torque that bolt to how much?
135.
135. The dial is going to tell me
117.
117. By the way, I don't like to talk much about myself or brag, but I'm probably one of the fastest people you ever meet at math. Somebody give me a difficult math problem. Go.
I have nothing. 9%.
What?
9%.
1,360 divided by 28.
49.
Oh, that was fast.
I told you I was fast. I'm working on accuracy next. After like, was he right? No, I probably have no idea. Said I was fast. I didn't say I was good. All right, same thing happens if I want to go backwards. This time I'll look at the numbers. Right there. The formula is a little different. It's T times L. That's the same. L minus E, because we're going backwards this time, equals Y. Well, we got the same 135 times the length. Was the length 10 inches? Length is 10 inches. Divided by 10 minus 1.5. And then now I realize it's right down there. So it's 1350 divided by 8. We're going to put 158.82 inch-pounds on the dial to get 135. So we have to go more, don't we? So we got to pull harder to get the same torque because this went backwards. Okay, there's a little trick now. What if this adapter was going this way? You can use either formula. Let's try it. 135 times 10 divided by 10 minus, well, what's the difference between here to here? Yes, I literally did it in the same spot. 0. Well, if you do that math, you're going to get 135. Which is to say, if it's 90 degrees, you don't have to do anything. To a point. If this were out here by, say, 10 inches, you would have a problem. It starts to get off, and then you actually have to use Pythagorean's theorem and do
Triangles.
a squared plus b squared equals c squared and all that stuff. I'm not going to make you do that today. Or on this ever. All right? So that's how you're going to do that. Now, if I were to put this on the test, what information would I give you?
Length of the wrench.
I would give you the length. Well, okay, what would I do? Let's just do this right here. Erase all ink. On a test, I would give you the following. Oh, we can just go over here. I would say, what should the dial say if we have a torque wrench that has a length of 12 inches? And I want the torque to be 125 inch-pounds. And we have an adapter that is 2 inches. And by the way, the formula is T times L divided by L plus E. I'd make that E for you. That'd make it easy. And I would give you all of that and say, you tell me what it is. And you could do that, right? Because it's right there. But I may not say L equals T equals E equals. I would say the torque wrench effective length is 12 inches. The torque desired is 125. And the extension that we're using is 2 inches, and it's going out from the... And I think you could do that, right? That's how I do my stuff. I explain how it works. I give you the formula. I might give you 2 formulas. Use either one of the following formulas, and you might have to pick the right one. But I give them to you. Because I'm nice like that. All right, we got that? You guys put this up here. All right, a few torque wrench rules here. Let's see. Things I forgot to say. I have a small problem. I don't see my pen. There it is. Okay. All right. The wrench size is not the bolt size. Do I need to write that?
No.
All right. Now this is something that I wrote. Let's see. A. What is A? It just says use proper torque. Use proper torque. Not everything in an airplane it has a torque. There's a lot of inspection panels on an airplane. You just tighten them. There's a lot of things you just tighten. But critical things you torque. B. This is something I said once. Do not use impact wrench. Unless allowed or specifically called out. I read some really good books on torquing procedures and why the preloading and all this. And in this book, I did talk about how we're trying to achieve a torque line that kind of looks like that to reach our objective, but an impact wrench kind of has impacts up to the point where you're going, so you actually exceed it, and then it relaxes, and it was bad. And so I've always had this thing about no torque wrenches. I don't use torque wrenches. Isn't it like, as I mentioned. So building all these engines, we never used torque wrenches. We didn't use, we never used a torque wrench, forget it. We didn't use impact wrenches. When I grew up in the body shop, I would literally get yelled at for not using an impact wrench on everything. Time is money. Money is time. Use an impact wrench. I was sitting there with a socket and a thing on my hand. It was like, what are you doing? Get out the impact wrench. It was nonstop. So I know what an impact wrench is, and I know how to use one. I rebel against it a little bit. So, but I read all this stuff about engines, and you shouldn't do it, and that stresses the parts out, blah, 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 and I wanted to build a perfect engine. So I never did it. And then I get here, and I'm teaching, and then I have students come in like, Kevin, let me show you this cool invention. It's called an impact wrench. I'm like, I'm aware of them. I choose not to use them. I also choose not to use electric screw guns on aircraft. I'll tell you about that in a second. So I, in the engine class, I show a video of Lycoming. They're doing a tour through Lycoming where they build these engines. And it must have been like the 10th time I'm watching it. And I look up, I'm like, the guy in the background, they all have air hoses with air impact wrenches building these Lycomings. I'm like, aha! I knew it, because every time I take apart a factory engine, there was a little fretting. There was something about them I didn't like. And I think it was that. I don't know. So I won't use them. I don't use electric screw guns on air. I do a little bit. I'll use them on the inside plates, but all the exterior panels that we take off for inspections, and there's a lot of them, I don't use electric guns. It takes a lot longer and we lose money doing it. But I don't do it for two reasons. One, you tend to strip out more screws than not. And ultimately, I think you spend about the same amount of time dealing with stripped out screws. And it's not nice to the customer's aircraft. Two, I got a call from the FAA. In fact, the same guy who asked me if I did human factors. Called me. He asked me. He said, "Hey, what are you teaching your people about electric screw guns?" I said, "Personally, I don't use them, so I don't really talk much about them." Why are you asking? He said, "Wow, you just watch the news." Somebody who was rather famous in the aviation community and very well liked somewhere up north, who I didn't know, was working on his airplane, doing an annual inspection, owner assisted. He was in the hangar, and he was using an electric drill gun to pull panels, inspection panels, off the bottom of the wing. Well, a lot of wings were called wet wings. They're just built with the aluminum and sealed, and fuel just goes in there. And he's working on a plane with wet wings, and it's got a panel that's sealed, and he starts undoing it. There's an electric gun, and it creeps and fuel just dumps out. And he's, "Oh crap!" Reverse, squeeze the trigger, and that was the last thing he ever did. Yeah. And so this FA guy, Chuck, he did some research into it, and I forget his numbers, but it was an astonishing number of AMPs die every year from the same thing. It was like 5 or 7 a year die from this. So he was looking into this and the safety thing. So
And they ignite the fuel.
ignite the fuel and explodes. Yeah.
All it takes is a little spark.
What's that?
It just takes a little spark.
Little spark. Yeah.
Yeah.
So-
So.
So one, I strips out screws, and it's not nice to the airplane. If you guys haven't priced out an airplane lately, they're very expensive. So Cessna 172s right now, you can't get one for under $100,000. I mean, you're talking about a 1970s or something. You're talking at least $100,000 for a decent one. You want to move into a 182, you're talking $250,000. You want to buy a new 182, you're talking close to $1 million.
Oh my god.
Oh shit.
Yeah. Engines, I mean, a tiny little engine. This one right here, you're going to be looking at well over 40. If you want to buy a new engine for my airplane, it's something like 80,000.
Oh.
Propellers are at least 10, 15 to. Oh, the guy I had a guy right here. He'll be second year now. His prop, I think he paid 40,000 for his propeller.
Has this changed with time? Has it gotten progressively more expensive with materials and
Litigation and shortages of aircraft. So if nothing else, safety aside and all that, notwithstanding using an FAA type word, these airplanes are stupid expensive, and when you screw up, it really costs a lot of money. So scratching one is really bad. I know every little scratch on my airplane. If there's a new one, I'm coming unglued. And they were there when I bought it. Let's see. Do not do that. Torque is based on bolt size, not the wrench. Not the wrench. Let me see. We talked about the different types of torque wrenches. Types. We have the click type, the dial, the bar, and electronic. They must be calibrated. Must be calibrated. How often you suppose?
16.
Annual?
Once a year.
General rule of thumb is annually, once a year. When dropped, that happens often. Or as per repair station manual, as per 145 manual. If you wrote something in your op spec manual for your 145 that's different, then you can get away with it. I know one person who said, why do I have to have it done every year? Can I do it every other year? And the Cal Lab said, put anything you want on there. There's no law for it says it has to be done. Although I have read some publications from manufacturers, like an engine manufacturer, and using a torque wrench that has been calibrated within the last year, do the following. Well, now you have to. All right. Use proper procedures. Which is to hold it properly. Hold properly. Do not jerk. Use steady, even pressure. G. Use the correct torque chart. All right, this is kind of a big one here. I haven't really talked about this yet. So if I want to torque something, there's a hierarchy of where I'm going to look for information. And to try and make it as simple as possible, the first place we're going to look is manufacturer specific. SPECIF. Specific item. In other words, I want to torque the wing bolt on my airplane. I will not go to AC 4313. I will not go to a general torque chart in the manual. I will read the manual until it says, and torque the wing bolt to, and it will give me a number. That is a very specific item. Or yesterday I torqued cylinders. Torque the 3/8 inch cylinder base nuts to 420 inch-pounds. Torque the 7/16 to 500 inch-pounds. It's very specific as to what it is from the manufacturer. Then now if the manufacturer doesn't say anything, sometimes they'll say, and torque the bolt. Okay, to what? Well, then I'm going to go to manufacturers, general torque. So if I'm working on my airframe and I was doing the wing bolt and it said, and torque the wing bolt, period. Like, well, they didn't give me any, and there's nothing in the book that says wing bolt torque. Now I'm going to go to the general torque page that has a chart that looks a lot like 4313, and it will give me a list of torques, and I'll look at the bolt size, not the wrench size, and I will torque it per that. Or sometimes I'm working on an engine, and I'm looking for just some nut that's not doing nothing, not doing a whole lot of anything, but it's there, and I want to torque it. There's no specific, so I'll go to the general and say, oh, 1/4 inch nuts, I'll get this torque. Follow?
Mm-hmm.
Okay. If I get nothing out of either one of them, and I tell you right now, unless you're working on an antique airplane, this is all you need. Right there, done. There are no other options. That'll cover 100% of everything. But I'll put that if working on an old plane, say 1940s, about 1940s vintage. I restored a lot of airplanes. The maintenance manual for vintage aircraft are, generally speaking, a few pages, 2 dozen pages. And it's more an operations manual. And so if you're working on something like that and no information. Info is available. Use, this would be 3, AC 43.13. The chart we've been looking at. That is the last resort chart. Working on a low 90 using info, but never on engines. Never on engines. 4313 is an airframe only, dry torque, CAD plated. It is not for engines. So what circumstance could I use AC 4313 to torque bolts on an engine?
Never.
Yes, never is the correct answer. But what if?
No.
No.
Thank you. But
No.
what if?
No.
All right, it doesn't come up. It's not a thing, so it won't happen. If you're working on a vintage airplane and you have a vintage engine on the front, there'll be torques in the vintage airplane engine manual, so you will be there. But still, one of the projects you get to do, not in this class, but in 310, 311, is disassemble a whole engine, put it back together, and you take it out and you run it, and it's a lot of fun. A lot of fun? A lot of fun. People have a lot of fun. But yet somebody will be sitting there with AC 4313 trying to torque the stuff on the engine. Are they correct?
No.
Okay. When would they be right in doing so?
Never.
Okay, thank you. All right, we talked about wet versus dry torque. Who uses a wet torque? Engines. Who's dry torque?
Frame.
Airframe. Okay, we talked about adapters. We did all right. I think we're doing all right here. Got that. Okay, safety wire. Safety wire is an easy module because mostly it's there's not a lot of rules and regulations and stuff to safety wire. So safety wire, stainless steel wire. There's different types of wire, but safety wire is used to hold critical things on the airplane. Although I gave you a list of critical items the other day on my airplane that are not safetied, and that includes all airplanes. Why? I don't know. It's such a random thing what they safety and what is not safetied. The things that I would safety don't even have the ability to, which would be hoses. I would always safety hoses. But nope, we don't safety hoses. So we are going to safety wire. I have a short little video that I did, my daughter held, which will explain some safety wire, at least let you see it. When I will expect you to know the rules of safety wire for tomorrow, but when it comes to doing safety wire in the lab, feel free to just grab me and go, can you give me a demo? And I'll grab maybe 10 people and hey, I'll give you a quick demo, but this is basically a quick demo. All right, hey friends, I'm here with my daughter Katie, who's doing the filming, and I'm going to give you a demo on safety wire. So I had to kind of set up a makeshift area here for myself, but these are the tools we're going to want to use. I like to use my safety wire pliers. I'm here with my daughter Katie, who's doing the filming, and I'm going to give you a demo on safety wire. So I had to kind of set up a makeshift area here for myself, but these are the tools we're going to want to use. I like to use my safety wire pliers. I will show you how to use those. Otherwise, I like to use duckbill pliers, wire cutters, and needle nose pliers. I'm going to be using 032 stainless steel safety wire, and I'm going to safety wire these two bolts right here. I'm going to get my safety wire out. The proper amount of safety wire is you want to do about twice the distance between here, plus about, I need about 10 inches for the size of my hand. So that's an appropriate amount right there. Cut that off. And of course, always wear safety glasses when you're doing this. All right, I like to straighten it out so that it's not all kinked up. And I'm going to start with this bolt here. Now remember, we have to have a positive pole, which means that it has to be pulling the bolt tight, righty-tighty, lefty-loosey. So I could start it from here and pull it around to where the hole is right here. That would be positive. Or I could start way over here, which I normally wouldn't, but I will not do it because just the way it won't work with the camera. So we're going to come around. So I'm going to pull this one tight. I'm going to go underneath. And notice I'm doing it all with my hands here. Get it tight. And I'm going to just twist it at a rate of about 6 to 8 twists per inch. Now you'll notice that it's a little loose right here. That's not bad. I can tighten it. And there's a way to tighten it, but you have to be careful not to over tighten it because it will break inside there. But what I'm gonna do it real slow. I kind of do a loop and bring it around. Normally I do it faster, and that tightened it up, all right? Now I'm gonna keep twisting it till I get to the hole right over here. Don't over twist because remember, you can't untwist safety wire. So you wanna stop before you go too far. Put it through the hole. This is where I like to use pliers because these are sharp little ends. All right, so I'll pull that in, then I'll use my pliers over here and I'll pull that tight right there. Bring that around. I'll pull this one in like that. And now this time I'm going to go backwards because I want this one here to come underneath this piece of safety wire. If you go this way, then it's going to want to tend to climb over the top of the head. So I go underneath, and again, 6 to 8 twists per inch. And if I want, I can give it one little around the world loop right there. And I like to go at least a full inch right there. Cut it so that you have about 3/4 of an inch sticking out. Now right there, that is a dangerous little thing. You have to hide your ends so nobody gets hurt. So I take that and I pull it right around into a loop. And I can run my hand over that and I won't get hurt at all. So that's how you would do it with that. Now I'll do this one and this one with my safety wire pliers. So again, I want an appropriate amount, not too much safety wire. I like to straighten it out. Now, there's an option you can do. This one has holes at every single head angle, and I got to plan it out so that it's pulling it tight. See, when I was done with this one, it's pulling this one tight, and it's pulling that one tight. That's going that way, and that's going that way. So this one, I'll come out about right here, but there's an alternate. When you have all of these holes, you can, if you like, put it through like this. And I'll use my pliers. And notice when I use my pliers, I use it out here where I'm going to throw away the end. I don't like any sort of tool marks on my safety wire because that creates a stress riser. And I will give it a couple twists to get started, just because. But here's the wonderful thing about safety wire pliers. So I'm going to go here. Now it does put tool marks in the wire, which is one of the reasons why I never do this inside of an engine. And you gotta be careful because these little wires are gonna whip around. And I just pull it until I get my 6 to 8 twists per inch, and I'm done. And then I always finish it off by hand so that I don't go too far. And it looks good right there. Bring it on through. Pull it tight that way, pull it tight this way. Now some safety wire pliers you can reverse them and twist the other way. Mine do not twist the other way. So once I get it started, I usually just clamp it here and then twist by hand like that. Give it a little loop like that so it's tight but not too tight. Cut it off. Hide my pigtail. Whoosh. And there we are. That's going positive pull. That's going a positive pull. Nice and tight, nice and tight. Kind of the test is if you can grab it here and pull it over the top of the head, it's too loose. Can't do it. Can't do it. So I'm going to call that airworthy. And there we are. How to safety wire. All right. Hey, friend.
Yeah. Oh, thought somebody had something to say. Okay. Safety wire. Let me see. Material. What kind of material do I use? All right. Oops. Safety wire. Material 1 is stainless. Stainless steel is the most common and used to safety nuts, bolts, and other hardware. Nuts, bolts, and other hardware.
That is only removed for maintenance.